All right, we're going to take a detour from what we've been using in our regular textbook, and we've got to do some pre-work on loading some algebra into your head before we hit Mod 6. So you should have this notes packet right now. It's kind of a preview talking about properties and equations. And what I want you to do is get to this first page. Okay, so you'll notice all of this. It's kind of bizarre. It says like 6P because it's module 6, but we're doing a little preview and we've got about 4 lessons that we're going to do. This first one is called using the distributive property. Okay, and I guess for our essential question today, I'm going to turn some ink on here. Oh, I feel like blue. Okay, how can I use the distributive property to simplify expressions? Use the distributive property Alrighty, question. All right, so we have to do a little bit of review on what commutative property and associative property are, and then we'll demonstrate what the distributive property is. So, commutative property, this is where we're saying things like 4 plus 3, which is 7, is the same value as 3 plus 4. Or if we were multiplying, okay, so you see how it works for addition. If I said 4 times 3, that's 12. 3 times 4, that's 12. They have the same value. So this has to do with the order. And this becomes important because we are going to move terms around using this property in order to simplify things as we go on, okay? Algebraically, it looks like this. If I have some number A and I add another number that I'm representing by the variable B, it has the same value as if I started with B and added A. Oh, sorry, that got a little smooshed together there. I don't like the way that looks. Erase. Let's make that look a little better. B plus A. All right, next, I have to do multiplying. A times B. Multiplying 2 numbers together has the same value of taking the B value first times A. Order does not matter for addition or for multiplication. The associative property has to do with grouping. And this is the one where we can take our parentheses. Okay, so I'm going to also put parentheses here. I could start with 1 plus 2 in parentheses and then add 3. Okay, now the parentheses mean do those ones first. 1 plus 2 is 3. 3 plus 3 is 6. What if I had the same order, 1, 2, and 3, but I put the parentheses around the 2 and the 3 instead? This says take 1 plus the value of 5. You still get 6 for your answer. The value remains the same. Okay? Likewise, if I was multiplying and I said take 1 times 2 in parentheses times 3. 1 times 2 is 2, times 3 is 6. Oh, this is weird because I get the same value. And I take 1 times the quantity 2 times 3. That gives me a value of 6. algebraically, using variables a and b, here's what I can say. A plus b, two numbers represented by these variables, plus c is always going to have the same value as, starting with my first variable a plus parentheses, the quantity b plus c. Okay. Same thing for multiplying. So if I'm multiplying a times b, put that in parentheses, take that quantity and then multiply by c. That means this, I'm going to get the same value as if I had said take a times the quantity b times c. B times c is in parentheses, do that first, and then multiply by a. Same thing. Okay. Distributive property. Here's really what we're getting at. If I have something like, let's say 5, and I want to take 5 times, and I have a quantity here. And I said something like 6 minus 4. My order of operations typically tells me take 6 minus 4 first, which has a value of 2, and then take 5 times 2, that's 10. Okay? I could also, though, do a different problem and say, you know what? This 5 times 2 is 10. This also is going to be the same as if I had taken 5 times 6, which is 30, and 5 times the 4, subtracting those two. That's 20. 30 minus 20 is 10. So I end up with the same value, and I did my operations a little differently. When I take 5 times that first number value, 6, and then 5 times that minus 4, or I'm going to say like a negative 4, minus 5 times 4, you end up with the same value. That's kind of crazy, okay? Algebraically, it's going to look like this. A times the quantity, I'm going to say plus first, b plus c equals a times b plus a times c. Okay, now you're saying, I don't know what this gobbledygook is you're talking about. Here's what I'm talking about. See this problem, this very first one? Here's what's going on. Old people like me, we didn't have handheld calculators. We had to make a simpler problem. So if I had to take 8 times, let's say $9.99, there's no way I'm going to come off to the side and start doing 8 times 9 and 72s and carry the 7. Yuck. Here's what I'm going to think about. I'm going to say, you know what? This is the same as 8 times $10 minus a penny. And then I'm going to use this distributive property, which says this. Take 8 times $10. That's $80. Then take 8 times this 1 cent. This was a subtraction sign. I'm going to start to train you to think of this subtracting 1 penny. I want you to think of it as negative penny, 1 cent. This is a much simpler problem because 80 minus 8 cents is going to be $79 and 82 cents. 92 cents. Good grief. 92. So here's what you're going to do. Right now, when we look at this, it says 3 times the quantity x plus y. That's the same as saying 3 times this first thing, x, and 3 times that second term, which is y. 3 times x is just 3x. I don't have to put the dot in there. Plus 3 times y. I have not given you any values for the variable x or the variable y. They're not the same. I'm not going to try to combine them together. That's all we can do to simplify it. Cool. So really, I want you to kind of think like there was a game called Angry Birds once upon a time that would kind of show you the trajectory or the path that you were launching things. That's what I kind of think of when I'm doing this. 7 times m, and then 7 times a minus 1n. I'm just going to say minus 7n. Different letters. You are done. Ooh, what's the deal here? This 12, when there's nothing in between there, is supposed to be multiplied. Just because it is on the right-hand side of the parentheses instead of the left-hand side of the parentheses doesn't matter. Distribute like this. You have to take 12 times b, 12 times z. All right. Now, I'm going to put the number 12, or it's called the constant when we start talking about algebra. I'm going to put that in front of my variable because it doesn't matter the order. 12 times b plus 12 times z. Boom. All right, let's start doing some more. You start cruising along. Pause the video and check and see how you're doing. Oh, here's another one that's on the right-hand side. It's okay. You're just distributing to both terms inside the parentheses. 4 times w, and I'm going to put my constant 4 in front of the variable. 4 times h. Last one on this page, 18 times k. 18 times t. And this is a subtraction problem. So I'm going to put a minus sign. That's all you can do because, again, I've said you have no values to substitute in for the variables, and the variables aren't the same. So we just have to leave those separate. All right, let's go to town. Notice now I have some variables and I have number values. 5 times x, 5 times 5. 2 times m, 2 times 3. 3 times y. Now, here's what I'm going to tell you. I want you to start thinking or that minus sign as stuck with that 7. Because I want you to think of this as 3 times negative 7. And remember your rules for operations. A positive 3 times a negative 7 is a negative number. 3 times 7 is 21. Negative 4 times r is going to be negative 4r. Negative 4 times a positive 6. Negative 4 times positive 6 is negative 24. Now, some people might want to write this way. Negative 4r, add the opposite, like plus negative 24. That's the exact same thing. These two are called equivalent expressions, okay? They mean the same thing. You can write it either way. Negative 9 times w. Ooh, careful now. I want you to think of that as negative 10, okay? Let's just say you aren't thinking that way. Negative 9 times 10 is negative 90, and there's a minus sign there. Minus a negative means add the opposite. The first term is staying the same, and this becomes plus positive 90. Okay, look at this. Negative 9 times negative 10 is plus or positive 90. You're going to have a whole lot of review of integers here. Negative 7 times b. Negative 7 times negative 5. Okay? So I want you to think of this as -7 times -5 is positive 35. Now, the -3 is by itself, but it's on the right. You're just going to distribute it forward. So you have 4x times -3. That gives me -12 times x. I have -3 times 6. That's a -18. I'm just going to leave it that way. -5 times 9. -5 times -10w. A negative times a negative is positive. 5 times 10, 50. Done. This one is on the right as well. Multiply the 8's together, but this is a positive 8 and that's a -8. -8 times a -9n. -8 times -9 is positive 72n. Sweet. Oh my gracious, these ones on the bottom are nice. -1. This time I have 3 terms to distribute -1 to. When you multiply something by -1, it just flip-flops the sign. 6. I get 12m. 6 times 4, 24. Okay? 48t. I'm going to add that down here. Sorry. I write big and I run out of room. This last one. Distribute the 7 times -2d. That gives me a -14d. 7 times, think of this as -4f, minus 28f. 7 times a positive 4x is plus 28x. 7 times a -8r is minus 56r. Boom. There you go. All right. So here is what I want you to do. Check in Schoology to look for your assignment. It's going to be in our big old packet of problems that you are getting for this part of the preview to Mod 6. Good luck and may the force be with you.